I welcome you to the organic chemistry class. Today we are taking the some points which are left over in the aldehydes and ketones. Yesterday we have taken, and today we will continue on this issue. So one of the important reaction in this aldehydes and ketones is a base catalyzed condensation reactions. Some details we will take today. Briefly I explain, but I will explain little more briefs. The aldol condensation is one of the reaction. Overall reaction, you may take it as a an example. If acetaldehyde is taken, acetaldehyde undergoes a condensation with the two hydrogens of the another acetaldehyde. The net reaction is it is catalyzed by the base. What compound you are getting means you have to write this continuity CH3, then CH, a double bond between the carbon and the second carbon of the other aldehyde and the CHO. This is known as a 2-propanol. This is known as 2-propanol, 2-butanol. This is an aldehyde at first carbon, ene at the second carbon. 2-butanol has a common name called crotonaldehyde. Crotonaldehyde. Most of the compounds products in the aldol condensation and the Cannizzaro reaction, they have a common names because the reaction is very old reaction. Prior to the IUPAC, probably all these compounds identified. Therefore, people started using these compounds much before IUPAC nomenclature establishing. Therefore, we have a very good common names like crotonaldehyde, acetaldehyde plus acetaldehyde. One acetaldehyde is using the oxygen. Another acetaldehyde is using the two hydrogens. Is it the so simple means no. The two hydrogens must be with reference to this carbon should be alpha. So the two alpha hydrogens only useful. If the compound is little bigger one also, you have to use only the two alpha hydrogens, right? Now what are the conditions required here? You can once again see. The first condition is it can be an aldehyde or ketone. There is no restriction regarding whether it is aldehyde or ketone, but having two alpha hydrogens. So this is the first condition. It can be aldehyde or ketone having two alpha hydrogens. An example you can take acetaldehyde. What is alpha hydrogen means? Leave the functional group, next immediate carbon is called alpha, then next we call beta, gamma, delta and so on. So we have 3 alpha hydrogen, therefore it is going to give. Okay, right. Similarly, if you have a CH3, CH2, CHO. So this is functional group, this is alpha, so we have 2 hydrogen, therefore it is going to give, and so on. We have a ketones like acetone. Acetone has 3 hydrogen, this side alpha, even that side hydrogens also called alpha. This underlined 3 plus 3, 6 alpha hydrogens are there. So therefore acetone also undergoes alpha this reaction. Similarly, a compound like butanone. Yes, butanone has 2 hydrogens here and 3 hydrogens there. So total hydrogens alpha is available is 5 alpha hydrogens. Similarly, a butanaldehyde, a carbonyl compound, and immediate carbon has 2 hydrogen, therefore it is eligible. All these compounds are eligible to show this aldol condensation. So 2 alpha hydrogens is the first condition. Second condition is in presence of a base, almost 50% the strong base it is. A concentrated and it is a strong base is required, for which we are taking the sodium hydroxide or potassium hydroxide. Rarely it is also mentioned barium hydroxide also here and there. but mostly the NaOH and OH. You can commonize also, the OH minus is enough in fact. However, we are heating, nominal heating, just heating is enough. No need to specifically so much of, actually water is deleted. You need not to go for the very high temperature, just around 100 degrees it is enough to promote the dehydration reaction. So therefore, the two conditions are required. One is all the aldehydes and ketones containing alpha hydrogen like acetaldehyde, propanaldehyde, butanaldehyde, pentanaldehyde and so on. In the ketones, acetone, this is propanone, this is 2-butanone or 2-pentanone, butane, all ketones also will undergo. Which will not undergo, this is also a very good example here. The compounds which are not undergoing aldol condensation or non-eligible, okay. So, not eligible for aldol. Which compounds are not eligible means a carbonyl compound has, if a carbon is there, the question of hydrogens will come. If a carbon is not there, let us say hydrogen is there, this is known as what? Formaldehyde. So formaldehyde is not able to show this aldol condensation. Similarly, let us have an aldehyde function attached to a carbon. This is alpha carbon. If alpha carbon is having the some other groups like all methyl groups, okay. So trimethyl acetaldehyde it is known as trimethyl acetaldehyde or 2,2-dimethyl propanaldehyde is also not eligible. Similarly, a carbon with all halogens is also not eligible to undergo aldol condensation. Similarly, an aldehyde which is having a benzene ring attached. In the benzene ring, you see this is the carbon. This carbon is known as alpha carbon, but there is no hydrogen on the alpha carbon. Therefore, benzaldehyde also cannot undergo. Benzaldehyde cannot undergo aldol condensation. Right? So, if alpha carbon is there, that should be having some substitutions like halogens or the methyl groups or aromatic system. If it is there, also not eligible. And similarly, ketones containing both the sides all alkyl groups. This also cannot undergo aldol condensation because alpha carbon is there, but it is attached with all substitutions, right? So similarly, a phenyl group, a C double bond O, a phenyl also cannot undergo the aldol condensation. So what you need is a 2 alpha hydrogen should be there. If the 2 alpha hydrogens are not there, the reaction is failing. But aldehydes and ketones both undergo reaction if it fulfills the presence of the 2 alpha hydrogens, right? So these are the conditions and these are the examples. Sometimes questions are asked that which of the following cannot undergo aldol condensation or can undergo aldol condensation. Examples: formaldehyde, trimethyl acetaldehyde, trichloroacetaldehyde, chloral, and benzaldehyde, and both the sides trimethyl groups, both the sides phenyls, that is benzophenone, cannot undergo aldol condensation. Okay, right. But among these compounds which are not eligible to undergo aldol condensation can undergo some reaction in the same reagent. For example, if a formaldehyde is there, if we add sodium hydroxide and heat it, what happens? Means it has no alpha hydrogen, therefore no aldol condensation. However, no aldol condensation. However, but it undergoes some other reaction. This is not, but it undergoes another reaction called a Cannizzaro reaction. Cannizzaro reaction. In this Cannizzaro reaction, 2 formaldehydes are reacting and one becomes into acid, that is formic acid. One becomes into reduction, this is oxidized. Reduction of formaldehyde gives the methanol. So this is a side reaction. In fact, compounds which are not eligible for the aldol condensation sometimes may undergo Cannizzaro reaction. However, Cannizzaro reaction is given by only aldehydes only. Only aldehydes, not the ketones. So aldehydes which are not having alpha hydrogen in the presence of sodium hydroxide can undergo Cannizzaro reaction. But fortunately we don't have much details about this reaction. Let us go for the details of this aldol condensation. Mechanism of this aldol condensation, let us see. In the aldol condensation, what is actually happening is one acetaldehyde is undergoing a nucleophilic addition with another acetaldehyde. This acetaldehyde is, we are breaking into the minus and the plus. This happens in presence of the OH minus. The plus is added on the O and minus is added on the carbon minus adds on the carbon and H plus adds on the O minus. So, one acetaldehyde breaks up into alpha hydrogen into a plus, the rest of the party into the minus and adds. So, and this happens to be step 1, this happens to be step 2. So, therefore, it is a nucleophilic addition reaction. Nucleophilic addition reaction. What happens in this reaction means if the H is added to O, O will become OH, right? O will become OH and the rest of the compound you continue. This is acetaldehyde, the rest of the party is CH2CHO, second acetaldehyde this is. So, one acetaldehyde is almost intact, but the hydrogen is added here, rest party is added to this one. This is the half of the reaction is completed. In the first half of the reaction, one acetaldehyde we are breaking into plus minus, the plus is added to O, rest of the molecule is added. This is a two-step reaction, first nucleophile followed by the electrophile is added. So, it is a nucleophilic addition. And here the OH has got always a hydroxy group will have a minus I effect, therefore, it want to go out. For which if hydrogens, silent hydrogens this side that side, no reaction, but one of the hydrogen it shows hyperconjugation with this hyperconjugation with the carbonyl group. Therefore, this hydrogen is reactive. So, this hydrogen and this OH together eliminates as a water. So, removal of the water, generally we use a concentrated sulfuric acid for the dehydration of the alcohols, but here we are maintaining a base. So, we cannot add all of a sudden sulfuric acid also, because already strong base is there. If you add sulfuric acid, temperature crosses over. Dilute sulfuric acid slowly you can maintain, but instead you can add some anhydrous magnesium sulfate or sodium sulfate in order to promote the water liberation. So, if you add this one slightly warm it, the HOH will be taken and forms into the hydrated magnesium sulfate or sodium sulfate. The compound will become into the unsaturated aldehyde or a ketone is formed. Unsaturation is between alpha and beta, therefore, the compounds are known as alpha beta unsaturated. Alpha beta unsaturated aldehydes are ketones depending upon the aldehyde or a ketone you have taken. So, therefore, unsaturated aldehyde or a ketones are the products. So, what are the products in the aldol condensation means alpha beta unsaturated aldehyde and ketones. Whatever the long chain you take 2 alpha hydrogens of one compound and add it to on this and after getting this in between compound is known as what? A beta hydroxy. Alpha beta hydroxy aldol, beta hydroxy aldehyde it is. And here an aldehyde function is there, a whole function is there, therefore, together this compound is called aldol. Aldol is not a scientist name. It is an in-between compound in the condensation reaction. So, their aldehyde if you start provided, the aldehyde is going to give an aldehyde in addition to OH containing compound. That compound is known as aldol. It is a combination of aldehyde and alcohol. 2 functionals are there. Therefore, this compound is known as aldol. So, however, aldol undergoes a dehydration and mild heating to give a alpha beta unsaturated aldehyde or ketone. What is the role of this OH minus, for which you can go one step into the mechanism of this reaction. First of all, what happens? One hydrogen is taken away by the OH. The one of the alpha hydrogen is taken away by the OH and that becomes into water. this acetaldehyde will become into the anion that is known as CH2 minus and the CHO. Now this will add on the second acetaldehyde. First acetaldehyde has become into a carbanion. So carbanion is involved as a intermediate species that will attack on the second aldehyde. It will open into minus and plus. On the plus, this minus will be attacking, and what you will get is a in between compound O minus, and the rest of the acetaldehyde you may write it. This is the in-between species. Now this will take the H plus from where the H plus is removed here and it is there in the water. So therefore, from the water you take this H plus and add it here. So you will get the aldol formation. This will become again into the OH minus. So what OH is doing? OH is taking alpha hydrogen, becoming into water. When once this anion attacks on the second molecule and gives this intermediate piece, then this a proton is given back to this O minus, so that OH is formed and aldol is furnished. This OH becomes into the OH. So therefore, the OH concentration in this aldol condensation will remain same. So therefore, the perfect role of the OH minus is as a catalyst. It is the maintaining. Catalyst will not used up. It will, if at all, if it is used, it will be regenerated at the end. The concentration of the catalyst will not be decreased in a catalytic. The property is the one of that quality of the catalyst. So here OH is used, again released at the end. So this H is taken temporarily and again given back to this O minus, so that OH is formed. That is the role of the OH minus. Now let us take a few more molecules and examine what type of reaction is taking place when acetone is taken. This also is a secondary reaction, leave it. If acetone is taken, how the reaction proceeds? This is acetone. So let us add another acetone on this compound. What we need is the first one is we need a carbonyl group, and another compound show alpha hydrogen separately. This is the only one, rest I am not interested. Now this break up into plus and the minus. Plus add here, however minus adds first and then plus is added. So the joint compound is now O will become OH, a methyl group show it here, and then this carbon, and the rest of the acetone is written here. So this is known as an aldol actually. But all is there. But is it aldehyde? No, it is not. It is a ketone I have taken. Therefore, instead of aldol, you have to say ketol. It is okay. It is a ketol is formed, but the reaction is studied with reference to the aldehyde. So therefore, name of the reaction has become a permanent as a aldol condensation. However, ketones undergo ketol condensation, but we are saying ketones also undergo aldol condensation. It has become a practice. Now this compound undergoes a dehydration when you heat it. So OH will take away here 3 hydrogen, here 3 hydrogens, but it prefers once again a alpha hydrogen is removed because it is in the hyperconjugation. So HOH is deleted. So the final answer will be this type of the compound. This compound has a name called mesithyl oxide. Mesithyl oxide. Acetone and acetone joint molecule has a common name, mesithyl oxide. Okay, and so on the reaction will proceed. Also, in fact, aldol condensation is not a end of the reaction. 2 compounds will join, you will get a dimer. The dimer further reacts, a long chain, a resin type of the products are formed. A polymerization is actually taking place, but we are studying the primary reaction between the first 2 molecules. What happens is a aldol condensation. Right? So different molecules you can take. The question can be asked, what is the catalyst? Base is the catalyst. So what is the role of catalyst? Catalyst will take the H plus and releases minus. What is the attacking species? Means one of the compound anion is attacking on the carbocation and a new bond is formed. This bond between this is one acetone, that is one acetone. So a new bond is formed. That bond will become a double bond when HOH is removed. Overall reaction you too can show like this. one acetone O, another acetone, 2 alpha hydrogens may be written, and like this, if one acetone if you draw, so the O and H2 is removed as a water. So this is a condensation reaction. Condensation is not a primary reaction. It has a first nucleophilic addition. Up to this is a nucleophilic addition reaction. This is the first reaction. This is the elimination reaction. Once this question is also asked, aldol condensation has the following the internal reactions. One is nucleophilic addition. This is the nucleophile followed by plus. After getting dehydration, this is an elimination reaction or dehydration. So nucleophilic addition followed by elimination is a condensation. Condensation as such is no more a primary reaction in the aldol in the organic chemistry. Organic chemistry primary reactions are addition, elimination, substitution. This is an addition, this is an elimination. Together we are calling it is a condensation reaction. One more reaction also I will explain in detail. Halogenation is also we have not covered yesterday class. Let us take some topic on the halogenation. The aldehydes and ketones undergo 3 different varieties of halogenation. One is a alpha halogenation. Alpha halogenation. So acetaldehyde, if I add chlorine, it doesn't require any catalyst. Just pass. This is a liquid, right? You pass the chlorine gas. Pass chlorine gas into the liquid of the acetaldehyde, one after the one, all these 3 hydrogens get substituted, you will get a trichloroacetaldehyde. Very much readily you will get this reaction because the hydrogens, as I said, they are in a process called the tautomerism. They are detached, and when minus comes back and the 2 electrons will come back, again the hydrogen is attached. This phenomenon is called hyperconjugation. The hyperconjugable hydrogens are very much reactive, right? So therefore all these 3 hydrogens one after the one halogenated to get this type of the trichloroacetaldehyde as a common name called chloral. However, only the chlorine is passed, you will get this compound and stops there. But however, the reaction is continued in presence of the base, okay, chlorine, and if base is used, then what happens? Then also the chloral, that is acetaldehyde, first becomes into the trichloroacetaldehyde. This trichloroacetaldehyde further, this is the step 1 is same, above step reaction. But if base is there, what happens, like a sodium hydroxide or a barium hydroxide or this one, haloform reaction taking place, it cuts into 2 pieces. One will become into CHCl3, the other piece will become into a carboxylic acid. It's a sodium salt, sodium hydroxide. If you use potassium hydroxide, you will get a potassium salt. Calcium hydroxide, calcium salt is formed. So one piece, this methyl group is becoming into the chloroform. In fact, if the reaction is carried out with bromine followed by the base, or bromine and base if it is used, first bromoform will be bromol will be formed. A tribromoacetaldehyde is formed, which on hydrolysis will give the CHBr3. If iodine is used, you will get the iodoform in the triiodoacetaldehyde followed by CHI3 is formed. In the last class, in the alcohol haloform, that is chloroform topic, we have taken this chloroform is a water-like liquid, bromoform is a brown color liquid, whereas here it is a yellow color solid. How do you call this CHI3? Iodoform. So the iodoform is a yellow color and it is also a solid. So therefore we can identify the reaction whether the yellow color is formed or not quickly, as well as if the solid is formed, you can filter it and take the weight divided by the molecular weight gives the moles. Therefore how many moles of acetaldehyde is taken? Let us say acetaldehyde and water is there. Okay, some x grams of acetaldehyde, water is there, from which so many moles of iodoform is formed. From this the grams, you calculate moles of iodoform, that many moles are acetaldehyde is, the rest is the water. So you can go for the estimation or the calculation of amount of acetaldehyde present in the given solution. The reaction is also common to the acetone also undergoes. For example, if acetone is there, add the chlorine and the base. If only chlorine is added, trichloroacetaldehyde is formed. Further reaction may replace even these hydrogens also. But if base is there, what happens? Immediately breakage takes place and you will get CHCl3 plus 2 carbon acid is nothing but the acetic acid sodium salt. Sodium hydroxide, if you take NaOH, you will get the sodium salt of the acetic acid is formed. Sodium acetate plus chloroform. If iodine is used, iodoform and the sodium and then potassium acetate or sodium acetate, depending upon the base salt, what cation that is there, that cation will be here. But one part of the CH3 attached to the CO will become into the chloroform or bromoform or iodoform. So which of the following compounds will undergo? We have had a beautiful exercise on the which following carbonyl compounds will give yellow precipitate when iodine and the base is added. So all the carbonyl compounds which have CH3CO function, including the acetaldehyde, acetone, 2-butanone, 2-pentanone, 2-hexanone, all two carbonyl compounds, including the first member acetaldehyde also will undergo this reaction, isn't it? So this is the haloform reaction. However, the carbonyl compounds also undergo one more type of the halogen reaction. All carbonyl compounds, when you treat it with the PCl5, the oxygen will be replaced with the 2 halogens. One that is 2,2-dichloropropane will be formed, plus that oxygen is given here, POCl3 is formed. This is the third type of the halogenation. The first halogenation is just alpha halogenation takes place if simple chlorine is formed. Second type of reaction is called haloform reaction. Haloform reaction, that is when base is a base and chlorine together you add, you will get a trihalo compound and bifurcation into the haloform and the sodium salt of the compound is formed. And if PCl5 is added, the O will be replaced and the 2 halogens are coming like this. So therefore let us go for the some questions which are not covered yesterday topic, and also today's topic also we will see in the questionnaire. Yes. The reagent used in the Wolff-Kishner reaction. The reagent used in the Wolff-Kishner reaction is, so in the Wolff-Kishner reaction, as I said, it is a total reduction of a carbonyl compound, and in this total reduction, the carbonyl compound CO is converted into a CH2C. This is called total reduction. For this reduction, we have used 3 different reagents. One is a concentrated HCl and zinc amalgam. When this reagent is used, the reaction is known as Clemmensen reduction. Clemmensen reduction. If otherwise, if you use the first hydrazine is used. Hydrazine is used, followed by you have to use a strong base like KOH or NaOH, heat it strongly, sometimes a high boiling liquid like ethylene glycol or sodium ethoxide will be taken, CH3CH2 ONA. Sodium ethoxide also will have a high boiling point. So either of that will be taken and strong base is added and heated. This hydrogen formed undergoes decomposition and gives this one. This is known as what? Wolff-Kishner reduction. Wolff-Kishner reduction. Both are name reactions. Concentrated HCl, zinc amalgam when used, the reaction name is called Clemmensen. If hydrogen is prepared followed by with this reagent, if decomposition which leads to give the again alkane formation is known as Wolff-Kishner reduction. We do have one more reaction, a HI, hydroiodic acid in addition with phosphorus. Also you can prepare, but this has no name, but the first two has got a names. So therefore what is the Wolff-Kishner reduction? It is first hydrogen, that is the first option, NH2 that is known as hydrogen. When you add hydrogen, you will get a hydrogen formation. The hydrogen on boiling with KOH, you will get the alkane formation. Next. What is the product obtained in the reaction of acetaldehyde with a semi-carbazide? As we have seen in the last class, we have the Y substituted ammonias, NH2 with Y. All these compounds undergo condensation with the carbonyl compound. If Y is OH, this is known as reagent is known as hydroxylamine. This is known as hydroxylamine. And answer will be called as a oxime. Answer is called oxime. In the case of NH2OH, you will get the oxime. If NH2 is used, this is known as hydrazine. You will get the C double bond O N NH2. This is known as hydrazone. Hydrazine, when it is used, you will get a hydrazone. If you have two more reagents with a similarity with the hydrazine is NH2 with NH phenyl. This is called phenyl hydrazine. You will get a phenyl hydrazone. NH2 with NH and a phenyl with two nitro groups. This is known as 2,4-dinitrophenylhydrazine. This is also called 2,4-DNP. This is orange color, derivative will be the red color one. Rest of the all others are white color precipitates. They are all white color precipitates. Similarly, we have a last reagent NH2 NHCO NH2. This is urea containing ammonia, and the condensation will be always takes place with the side of the amino group, not with the side of the amino attached to CO. Amino attached to CO is known as amide group. Amides will not undergo condensation, only amines undergo. So therefore, the carbonyl group undergoes with NH2 which is attached to the N, not the NH2 attached to the CO. NH2 attached to CO is known as amide. NH2 attached to N is known as amine or hydrazine. So therefore, this amino group undergoes a condensation with this one, and these two eliminate as a water. You will get a C double bond N NH CO NH2. These products are called semi-carbozones. The reagent is called semi-carbazide or semi-carbazine. That gives the semi-carbazone in the answer. So answer 1 is the right answer. Next, the synthesis of crotonaldehyde. Crotonaldehyde is nothing but a two acetaldehydes undergo aldol condensation. He was asking the synthesis of crotonaldehyde from acetaldehyde is an example of what reaction? It is a nucleophilic addition, the condensation. I said condensation is not a primary reaction. It is first nucleophilic addition followed by elimination is also taking place. So the right answer is the answer 4 is the right answer. The match the following columns. Column 1 is a Grignard reagent A. A is the Grignard reagent, which is nothing but the CH3 methyl magnesium halide, that is third one. So the A goes to 3 means the 1 and 2 may be the right answers. Clemmensen reduction, concentrate HCl and zinc amalgam, that is 4. So B goes to 4. Again we have a still option between 1 and 2. So the Rosenmund reduction is the hydrogen, palladium, barium sulfate. Rosenmund reduction is acid chlorides will be reduced to aldehydes with the Lindlar's catalyst, that is the first C. Rosenmund reduction goes for the column 2, answer is 1. So the C for 1 is now the option 2 will be the right answer, right? So automatically the fourth one will be the identified. What is X in the following reaction? So acetone and acetone, two acetones are joined here. So the two acetones joined means aldol condensation reaction. One acetone plus another acetone. However, the reaction may be written like this, CH3 COCH3. But we have to understand, as I have shown, one acetone you write like this, or otherwise second acetone you bifurcate this one alpha hydrogen separately and the rest of the acetone. So the addition will become very easy, identifying the answer will be very easy. The hydrogen is added here, rest of the carbon, this is plus party, isn't it? Alpha hydrogen adds on the O, minus party adds on the carbon. This is the step 1. That's why it is a nucleophilic addition reaction. So what will be the answer means, now the CH3, the C with O will become OH and down CH3, and the continuation of the second acetone CH2 with the C double bond O CH3. Now search for this answer in your the options. You must have a clear answer. This answer you have to search for the from the ABCD. So the first one is the right option. What is X in the following reaction? Acetaldehyde again undergoing a condensation with another acetaldehyde. Similar to this reaction, if you have a thorough knowledge on the nucleophilic addition, a second acetaldehyde you write like this. So split up and add minus party on the carbon, H on the oxygen. So what you will get is a CH3, C with O will become OH, that is called aldol. So and rest of the CH2, CHO. This is called actually aldol. It's a beta hydroxy carbonyl compounds. Third carbon is nothing but the first, second, 3 hydroxy are with reference to this functional group alpha carbon, beta carbon. So we call beta hydroxy the aldehydes and ketones, also known as aldols. So the aldol is formed. That is nothing but the answer. The answer 3 will be the right answer. Next, acetaldehyde when treated with the dilute sodium hydroxide, answer 3 is the right answer. Next, 8th one, ammonical or ammoniacal solution of silver nitrate is called. As I said, the aldehydes undergo ready oxidation when compared with the ketones. In the oxidation reaction, the last class we have covered, under the oxidation we have mild oxidation and the strong oxidation. The mild oxidations are 3 types. One is Tollens reagent. What is Tollens reagent? A silver nitrate is taken and added some sodium hydroxide so that silver oxide is formed, a black color precipitate is formed. This is added excess of the ammonium hydroxide, Then this silver amine complex is formed. NH3 with taken twice, a complex with the silver will be plus. Okay. So in this silver plus, when you add to the aldehydes contain one hydrogen which is ready to oxidize. If that reagent is added, what happens? Ag2O you take. Ag2O if you take, this oxygen is given to here so that it will become into an acid. Aldehyde will become into the acid. This is an oxidation reaction. Silver is in the form of +1 which is reduced to the Ag0. This is a reduction reaction. So the aldehydes are oxidized to acids, and silver which is there in the form of the silver oxide Ag2O. Ag +1, Ag2O. That Ag2O will become into Ag0. So therefore it is a reduction. So the silver formed will get precipitated, and in the test tube all the inner walls, that silver will be slowly attached and precipitated, settled on the inner walls of the test tube. Looks like a silver mirror. The test is also, therefore it is called silver mirror test. So only aldehydes will give, because aldehydes has got this particular advantage. Ketones have no such hydrogens. An alkyl group is there. If you want to make acid, you have to cut this one. This is difficult. So therefore the same Tollens reagent if you add, there is no reaction taken by this aldehyde. Only aldehydes will give. Ketones will not give this reaction. So therefore you can differentiate using this Tollens reagent aldehydes from the ketones. Next, reduction of acetaldehyde in presence of lithium aluminum hydride. So acetaldehyde undergoes reduction with the lithium aluminum hydride. A small the mechanism may be shown here. Acetaldehyde will contain CH3, C double bond OH. Lithium aluminum hydride may be taken as a combination of the lithium hydride plus aluminum hydride. metal hydrides, both are metal. Now the lithium hydride being a more reactive, this will be added. How? The bond is polarized, you will get a minus and plus. On the plus, the H minus is added. So also nucleophile type, H minus is added here, O will take the lithium. So therefore, consequently, a CH3O, O will become a minus with hydrogen OH, and here there is a hydrogen, no, lithium is added here. So therefore, a lithium, O minus lithium, and one more hydrogen. So lithium salts are readily undergoes hydrolysis. Even if you don't add water also, with the moisture available also, it undergoes hydrolysis to get this ethyl alcohol. If you add water, it is welcome, you will get the ethyl alcohol. Even if you don't add water also, lithium salts undergoes hydrolysis aerially and you will get this ethyl alcohol. So therefore, acetaldehyde is reduced to the ethyl alcohol. So that is ethanol will be the right answer. Next. A few drops of an organic compound liquid are added. This liquid drops are added to the Schiff reagent. A pink color is produced. Organic compound is. As I said, there are three reagents: Tollens reagent, Fehling's reagent, and Schiff reagent. However, the Schiff reagent is a little complicated one. It is an organic base known as para-rosanilin. Para-rosanilin. Para-rosanilin is an organic base which contains actually a pink color. Originally it is pink color, for which we are adding sulfur dioxide by taking sodium sulfite or bisulfite, add some HCl, SO2 gas will be produced. That will decolorize this solution. You will get a clear solution, a clear colorless solution. Colorless solution, which is known as a Schiff reagent, So what is the color of the Schiff reagent? No color, absolutely no color. It is a colorless clear solution obtained by the decolorizing the pink color of the para-rosanilin. Is an organic base. Now this the Schiff reagent is added to the aldehydes. Any aldehyde you can take. Aromatic aldehyde slow, very slow, therefore some books gives a benzaldehyde will not give this fast reaction. However, all aldehydes, when you add this Schiff reagent, immediately the sulfur dioxide which is there here will be added here. Again this pink color will be formed. Why? Means all the sulfur dioxide which is there in Schiff reagent will be taken away. It undergoes a nucleophilic addition with the aldehydes fastly over a ketones. If you take ketone, also you will get pink color. But the time will be lot of time. Lot of time is required to get this pink color. Therefore, immediately aldehyde and ketone you add at the Schiff reagent, immediately if you get, that is an aldehyde. After some time if you get, don't consider that is an aldehyde, it must be a ketone. Okay, next. So aldehydes are the right answer. A compound A, C3H6O, undergoes following reactions to form B and C. Identify A, B, C. So a compound, in between compound is given. So the compound A is a C3H6O. This formula goes for the, either it can be an aldehyde or it can be a ketone, a propanone or propanaldehyde. But one side he says a zinc amalgam concentrated HCl, it gives a, this is compound A, this gives a this side product is C. So reduction, it is known as Clemmensen reduction. Clemmensen reduction gives a compound C. The same compound, if it is treated with the iodine and NaOH, it gives a CHI3. Yellow precipitate, he says, that is compound B is formed. That is a compound B is formed. Iodoform means the compound B must be iodine, sodium hydroxide means CHI3. And C is a Clemmensen reduction. If it is propanaldehyde or the propanone, this must be the same common answer. This one is the alkane, the other one is this one. In between A can be propanaldehyde or propanone. Let us go for the answering. So the first one is the option itself, I think it is very clear. The acetone is taken, propanone, and reduction one side the product C is a propane, that is Clemmensen reduction, and the iodine and KOH iodoform, that is a befitting answer. 1 is the right answer. Next. Acetaldehyde forms a white crystalline precipitate on mixing with a solution of the so 2 answers we have to say. This is a reaction of sodium. White crystalline product is from the sodium bisulfite, NaHSO3. So this undergoes a nucleophilic addition reaction with the aldehydes and the ketones. Both aldehydes, ketones undergo this reaction. The solution should be a aqueous, that is water dissolved, but it is saturated. Why it is saturated means the after added, if more water is there, the product formed, that is the derivative formed, will dissolve in that water. So therefore you prepare a sodium bisulfate dissolving in water to prepare a saturated, that means go on add it till the compound no more dissolves, that is called saturated. If such a compound is added, the product formed is already it is saturated with sodium sulfide. So therefore organic compound, whatever the compound you take, either aldehyde or a ketone, if you add this one, you will get a white color precipitate. What is that compound? Added compound will be formed. O will become ONA, and the entire HSO3 will be added one side. So this compound is a crystalline, white crystalline product is formed. So therefore aqueous solution and sodium bisulfite, that is third answer, is the right answer. What is the catalyst used in the conversion of acetaldehyde to acetic acid? Acetaldehyde to acetic acid, it is an oxidation reaction. Acetaldehyde to acetic acid is an oxidation. CH3, mild oxidation it is. Acetaldehyde to the acetic acid is a mild oxidation. You can use MnO2 or Mn, manganese acetate. Acetate means CH3, COO, manganese acetate. Dichromate acids also you can use, but the lithium aluminum hydride is a reducing agent. Second one not option. Hydrogen nickel reduces to ethyl alcohol, and the third one sodium ammonia is also a reducing agent. Therefore only the one option left over is manganese acetate it is. What is the gas liberated when alkaline formaldehyde solution is treated with hydrogen peroxide? This is the property of the one of the property of formaldehyde. Formaldehyde being a one carbon aldehyde, it has this side and this side, both the sides aldehyde functions are there. It has slight difference from the rest of the aldehydes. When hydrogen peroxide is added, it is undergoing oxidation into it undergoes a reaction to liberate the oxygen, that is carbon dioxide is formed and hydrogen gas is liberated. Hydrogen gas is liberated. So O is absorbed here and the hydrogen gas is liberated, that is the answer. Hydrogen, that is answer 4 is the right answer. Next, the chemicals used from preparing acetophenone, used for the preparation of the acetophenone. You must know what is acetophenone. Acetophenone is a phenyl COCH3. The group is called acet. Acet and phenyl with a own, somebody said it is acetophenone, the common name however, acetophenone. Systematically it is called methyl phenyl ketone, methyl phenyl ketone or methyl phenyl methanone, that is the IUPAC name. So how do you prepare? Means naturally we need a benzene, right, in order to get this benzene, and the acetylation CH3COCl or acetylene anhydride and anhydrous aluminum chloride. For the Friedel-Crafts acylation you can prepare this reaction. So therefore we need benzene, first answer is right, acetone is wrong, acetyl chloride, so third answer is right, anhydrous aluminum chloride, fourth also right. Therefore 1, 3, 4 is the third question is the right answer. When acetaldehyde is treated with the lithium aluminum hydride, what is the product? Just now we have discussed, it is the ethanol, it is a reduction, that is answer 2 is the right answer. Which of the following converts acetone into acetone oxime? As we have seen 5 reagents, NH2OH, once again I will give this clue, NH2OH will give the oximes. NH2, NH2, this is hydrazine. Hydrazine will give the hydrogens. Hydrazine will give the hydrogen. And we have a NH2, NH phenyl, phenyl hydrazine, phenyl hydrogens. And phenyl NH2, NH with phenyl with the 2 nitro groups, that is called 2,4-dinitro phenyl hydrogen. And finally NH2, NH CONH2, that is urea containing, this is called semi-carbazine, which gives semi-carbazine. All the reactions are condensation reactions. Here some of the options are there here. So what he wants is an oxime. Oxime means NH2OH. The fourth answer is the right one. Next. Which of the following compounds undergoes aldol condensation? As we have seen, for aldol condensation we need a carbonyl compound which contains alpha hydrogens. In the first one you see acetaldehyde has 3 hyperconjugable alpha hydrogens. In the second one it is a trimethyl acetaldehyde. Trimethyl means an aldehyde group is there, but the carbon has all 3 methyl groups are there. If a trialkyl system is there, there is no alpha hydrogen, therefore it will not undergo. And the third answer is trichloroacetaldehyde. An acetaldehyde with 3 chlorines. If a base is there, it becomes into chloroform, but not the reaction. The last one is H with CHO. So there is no alpha carbon, therefore there is no question of the alpha hydrogen presence. So the first answer is the right answer, that is acetaldehyde undergoes aldol condensation. Propanaldehyde and acetone can be distinguished by testing with. So first of all you must identify propanaldehyde is a aldehyde. Propanaldehyde is a aldehyde by virtue of the structure. If you see, there is one hydrogen attached to the O. This is called the aldehyde hydrogen. In the propanone we have a ketones, both the sides methyl groups are there. Here also we have 2 hydrogens. Aldol condensation, this undergoes here 3 and 3 both undergoes aldol condensation. But the question is here is how do you differentiate? Not by the aldol condensation, both undergoes aldol condensation. Here it is by oxidation methods we are able to differentiate. We have 3 reagents, either by adding the Tollens reagent. Tollens reagent will give a ammonical silver nitrate, which gives a white color precipitate when I add Tollens reagent. You can also go for the Fehling's reagent. Fehling's reagent is nothing but a copper sulfate, Fehling A. Aqueous solution of copper sulfate is Fehling A. It's added with the alkaline solution of sodium potassium tartarate, that is Fehling B. Both should be, we only have to add. In the market added reagent will not be, because the copper gets the decomposing. So therefore previously you should not add. In the market we have a Fehling A solution separately, B solution separately, A and B 1:1. You have to mix it and prepare a Fehling's reagent, immediately add to the aldehyde, wherein the copper Cu2O will become into the CuO will become into the Cu2O. That is Cu plus 2 is converted to plus 1. In the Tollens reagent, Ag plus is converted to Ag0. So you get a silver mirror formation. In this case a red color precipitate is formed. Third one, just now we have taken a Schiff reagent. A Schiff reagent also helps if a pink color is formed, it is an aldehyde. Okay, with the Tollens reagent, if a silver mirror is formed, Fehling's reagent red precipitate, Schiff reagent pink is formed. All these 3 reagents, any one, if you get a positive, that is aldehyde. Okay, if a ketone, all these 3 reagents will get a negative test. Thereby you can differentiate the aldehydes from the ketones. So the Fehling's reagent is there. First one, phenyl hydrazine, that reacts with both. Hydroxylamine, it reacts with both. Sodium bisulfite, both reaction. Only thing is for fourth one you can go slightly, which gives faster one. Aldehydes gives faster, ketones slowly. But all 1, 2, 4 reacts both aldehydes and the ketones. Only the Fehling's reagent, aldehydes reacts and you will get a red color precipitate, ketones no reaction. So therefore either Tollens or Fehling or Schiff you can use. Next, the reagent that gives an orange colored precipitate with acetaldehyde, orange color precipitate means just now we have seen there are 5 reagents ammonia. This one, the only one reagent, even the reagent itself is colored in fact. NH2 with a Y. What is that Y? Y is a NH with a benzene. If the benzene is there, this is called aniline attached to this one. But in the benzene also we have 2 nitro groups. These 2 nitro groups here -I -M. Therefore, pair here is a pulled down. So, the pair here will have a more reactivity. Therefore, one pair is deactivated. This pair alone will be the active to undergo nucleophilic addition. Therefore, one-sided addition reactions, all carbonyl compounds undergo condensation reactions like this. The products are called 2,4-dinitro 2,4-DNP. This is okay. 2,4-DNP will give a 2,4-dinitro phenyl hydrogens. The reagent itself is an orange color. The crystalline powder dissolve in alcohol. And a few drops, the moment you add, you will get a beautiful red color or orange color to red color precipitate. If it is aromatic, you will get a beautiful red color. If it is an aliphatic, red to orange type of the crystalline derivative. Other oximes, hydrogens and phenyl hydrogens, semi-carbogens are white in color, and 2,4-DNP, because of the 2 nitros, the extended conjugation is therefore it is a colored one. So, except this 2,4-DNP derivative, all other products are white in color. The red means it should be a 2,4-DNP reagent, that is 2,4-dinitro phenyl hydrogen will give a corresponding derivative. That is the right answer. Next. Acetone on reaction with chlorine gives a normally. So, here the question is slightly ambiguity is there. As I said, halogenation is 3 types of halogenation is there. All the carbonyl compounds containing alpha hydrogens readily undergo reaction. All this gets chlorinated. If hydrogen is there, you will get a trichloroacetaldehyde. That will be the end of the reaction. But if the chlorine is mixed with base, chlorine and base, if it is there, undergo a haloform reaction. This is the alpha halogenation takes place with only chlorine. Chlorine is a gas, this is a liquid, pass gas into the liquid, you will get a trichloroacetaldehyde, that is called chloral. If a chlorine and base is there, haloform reaction leads to break up this compound, you will get CHCl3 and the HCOO minus corresponding the metal ion will be there, is a salt will be formed. The similar the case if acetone is also. Acetone, if it is taken, there are 6 alpha hydrogens are there. Okay, if excess of chlorine and excess of time is there, actually you will get a 6 that is hexachloroacetone. Do you have a hexachloroacetone? Yes. So, but in the case, that's what the question is a slightly ambiguity question. If excess of chlorine is given, excess time is given, definitely perhaps the question hexachloroacetone will be coming. But initially what happens, a trichloroacetone, that is acetone, will be formed. If base is there, what happens, you see? If base is there, chlorine as well as base, if it is there, then first this is formed, it undergoes cut to get a chloroform and acetic acid, not the trihaloacetic acid, just acetic acid salt with the metal ion will be formed. Therefore, we can take it to grant that only one-sided halogenation taking place. You may also ask, why not one halogen this side, one halogen that side? All the hydrogens are equally actively reactive when acetone if you take. But if one of the hydrogen gets substituted, let us say, imagine, then this halogen will have a minus I effect, it pulls. Therefore, the hydrogen of this carbon alone will be more reactive when compared with the other hydrogen side. Therefore, this also get halogenated. When the 2 halogens are showing minus I, this hydrogen will become more reactive. So, therefore, this also will get the substituted. So, already all the 3 halogens, one-sided reaction takes place until unless 3 halogens comes, then the halogenation that is second carbon will not be touched. That's why trihaloacetone is formed. If the base is there, automatically it cuts. That's why acetic acid, the sodium salt or potassium salt is formed. Instead of, if the hexahalo is formed, you should have get a trihaloacetic acid, but never you will get like that. If a chlorine base is added, one side carbon will become into trihalo, that is methane. The other side you will get acetic acid. That is inevitably shows that only one-sided halogenation takes place and then it decomposes into the product. Therefore, the answer 3 is the right answer. It is a slight ambiguity there, but still you can that is justify that the answer 3 is the right answer. So, I think next that's the 22. The reduction of acetaldehyde by so and so leads to the formation of ethanol. So, acetaldehyde is the reduction, acetaldehyde to ethanol. We have a variation in the reagents. Acetaldehyde is reduced to ethanol. Ethanol means a O will become OH, the 2 hydrogens are there. So, what is the reagent you need? So, 1H, for which you can take hydrogen nickel, you will get this reaction. You can add lithium aluminum hydride, you will get this reaction. You can add a sodium borohydride, you will get this reaction. Finally, you too can add also what he has given. See, Tollens reagent is an oxidizing agent, therefore remove it. Hydrogen nickel is the right answer. Lithium aluminum hydride is also right answer. So, therefore, I think 2, 3 is the right answer. So, answer 4 may be the right answer. Even hydrogen nickel will give ethanol. Answer 4 is the right answer. So, slightly maybe ambiguity may be there here and there, but it is inevitable to show that if reduction is taking place, these are all mild reducing agents. If a reagent like Clemmensen reduction or the Wolff-Kishner reduction, total reduction if you do on this compound, what? These are all mild reductions. If the total reduction if you do with the Clemmensen reduction or Wolff-Kishner reduction or with the HI and phosphorus, you could have get a ethane. Total reduction gives the ethane, partial reduction gives the ethanol. So, with this I think we can conclude this the topic of the carbonyl compounds. In the next class we will go for the carboxylic acids, that is a carbonyl group attached with OH is known as carboxylic acid, that we will take up in the next class. Thank you.